All right, so the first question we're going to take a look at is just classifying an angle based on its size. Okay, so the first one has an angle that is larger than 90. So do we remember what that's called?
Obtuse.
Yeah, that's obtuse. Good. Okay, the second one, it's smaller than 90. What's the name of an angle that's smaller than 90? Yep, that's acute. And how about an angle that is exactly 180?
Straight angle.
Yep, that's called a straight angle. And there's one more angle I didn't draw, and that would be an angle that makes like an L, capital L shape, and it would be exactly 90. What do we call that one? Yep, that would be a right angle. Yep. So when I ask you to classify an angle, that's pretty much what I'm looking for.
Okay.
So the next one we're going to take a look at is converting between radians and degrees. There's two problems where we're going to leave the answer exact, and there's two where we're going to round to 2 decimal places. All right, so let's start with 3 pi over 2. We've got radians in the top. Again, it's invisible, but pretend like it says RAD right next to pi. So where would radians go in this fraction on the right to cancel out the radians that's in the top on the left?
The bottom.
Yep, it would go in the bottom. So radians goes in the bottom, and that means pi always goes with radians. And what unit is going to go in the top?
Degrees.
Yep, degrees. And what's the number that we always associate with degrees? Well, Joe, what do you think?
What was the question?
The number that we always connect with degrees.
What in terms of like?
To fill in for that fraction, for the conversion.
180.
Yep, so 180. And then when we multiply, pi's cancel. How many times does 2 go into 180?
90.
Yep, 90. So when I do out what's left in the top, what do I get when I multiply?
270
Yep, 270
degrees.
degrees. Yep. Okay, so that's that one. And now the next one is the same. We're just going to use the calculator and get a decimal.
Okay.
So what would we multiply by to change from radians to degrees?
180 over pi.
Yep, multiply by 180 over pi. And we're just going to type it in and see what we get. So it's 4.67 times 180. And how am I going to do the division part? I'm going to divide by what?
Pi.
And how am I going to type that in?
When you do second and then the up arrow.
Yeah, we're going to do second because we don't want to use 3.14. That's more accurate. So that's 267.57 degrees. Okay, so that's converting to degrees. And now let's try the other way, convert to radians. All right. What would we multiply by to change it the other way?
Pi over 180.
Yep, it's going to be pi over 180. And we can reduce before we multiply. What goes into 30 and 180?
6.
6? Yep, how about even a bigger number?
30.
How much?
30.
30, yep, that's as big as you can go. Can't go bigger than that. So 30 goes into itself once. And how many times does 30 go into 180?
6 times.
6 times. So that leaves you with what for your final answer?
Pi over 6.
Perfect, pi over 6. And the last one is the same type. We're just doing it with a decimal. Okay. So what do we multiply by to convert from radians to degrees?
Pi over 180.
Yep, pi over 180 degrees. Degrees cancels out. I could have done that on the last one too. I just didn't do it. And now we type it in. So 1.26 Remember, always use the pi button, and then divide by 180. All right, so that's 0.02. Well, if we're going to 2 decimal places, 0.02. And no label on that because it is in radians. Okay, any question on that? Okay. All right, so the next one we're going to look at involves finding the length of an arc. And the first thing that we need is the formula. Okay, what is the formula that has arc length, radius, and angle in it?
S equals R times theta.
S equals R times theta. Okay, what's the S?
Arc length.
That's the arc length. So we do have to know which one goes where. What's the R?
Radius.
That's the radius. And theta? The angle, anything special about the angle? Has to be in radians. Yep. All right, so let's see if we can find our arc length. So S we don't know. What's the radius they give us?
4 centimeters.
4 centimeters. And what's the angle they give us?
2 pi over 3.
2 pi over 3. If you want to make the 4 a fraction, just to make it next to the other fraction, you can just put it over 1. And when we multiply, we go straight across. So what are we going to get in the top?
8 pi.
8 pi. And the bottom?
3.
3. And we need a label on that. Okay. What did we just find?
The length of the arc.
The length of the arc. Yep. And in this problem, what unit did they use to measure length?
Centimeters.
Centimeters, yeah. So centimeters was the unit of length in that problem. Okay. So they'll always give you 2 out of 3 of the variables, and you have to solve for the one you don't know. All right, let's look at this one. So this one says find the radius, and this time they give us the arc length and they give us the angle. Anything you notice in that one that we're going to have to take care of right away?
That's in degrees and not radians.
Right, we can't use 45 degrees. We've got to change that to radians. Does anybody remember off the top of their head what 45 degrees is? Yep, pi over 4. If you didn't know, just convert it like we did in the last couple problems. All right, so now we're ready to fill in. Did they give me S?
Yes.
Yeah, what's S? 5 feet. Did they give me R?
No.
No, that's what I'm finding. I'm finding the radius. And did they give me theta?
Pi over 4.
Yep, pi over 4. All right, so now we want to get R by itself. So how can I get that pi divided by 4 onto the left side?
Divide both sides by pi over 4.
Yep, I can divide both sides by pi over 4, which is the same as multiplying by
4 over pi.
4 over pi. Yep, exactly. So times 4 over pi. The 4's are gone, the pi's are gone. That gives you an R. And what do you get on the left side?
20 over pi.
20 over pi. And what did we just find?
E. Is it in feet?
Yes, this is in feet because the radius is a length measurement. So you should have a label of feet. All right, so next question we're going to look at focuses on unit circle trig. In this problem, they've given you a coordinate, and they said that that coordinate represents the location of an angle on the circle. What angle, we don't know. I mean, we do know, but you don't need to know. Okay, the most important thing with unit circle trig is that you figure out
Coordinate.
the coordinate, and they've given that to you. So that's what you really need, right? So let's start with the sign and use our coordinate to get the sign. Okay. What is the sine of the angle represented by that location right there?
1/2.
Yep, that's going to be a 1/2. How about the cosine of the angle represented by that location?
Negative root 3 over 2.
Negative root 3 over 2. And now to get the tangent, what do we do with the trig functions up above?
Divide.
Divide them. So what I do is, again, I just imagine putting a fraction bar right there. If I divide those two numbers, what happens?
The 2's cancel out.
Right, same denominator, the 2's cancel out. So you're left with -1 over the square root of 3. But then we have to fix it so the square root's not in the bottom. And what do you get when you fix that?
Root 3 over 3.
Negative root 3 over 3.
Negative root 3 over 3. Yep. Okay. So now once we get the three trig functions on the left, what do we do with those to get the 3 on the right? Flip them, yep. So if you flip the sign, that'll give you the cosecant. So in this case, the cosecant is +2. Yep. What's going to be my first step to getting the secant? You don't have to give me the final answer, just give me kind of the initial step.
Just flip it.
Mhm.
So it's -2 over 3.
Over 3. And now I need the final step when we fix that so the root's not in the bottom.
So it's 2 root 3 over root 3? No. Because, or is it, I don't know. You multiply.
2 root 3 over 3.
-2
Oh,
root 3 over
negative.
3.
Oh, okay.
Right. And how about the cotangent? What's that going to be?
Root 3.
Negative. You can go.
Negative root 3.
Negative root 3. Yeah. Yeah. So we got to just be careful with those negatives and positives.
Yeah.
Any question on that one?
So we're just, yeah, never mind. I'm
Yeah,
good.
that's it. Okay, so this question, similar to the last one, except this time they're giving us an angle to start with. If they give us an angle, what's the first thing that we need to figure out?
Put a coordinate.
We got to figure out the coordinate. And for 30 degrees, because it's in quadrant 1, that's a coordinate that we want to memorize. What is the coordinate for 30 degrees?
Is it? Oh.
Root 3 over 2 and 1/2.
Yep. So it's root 3 over 2, 1/2. So that I should have put in this box. Root 3 over 2, 1/2. Okay, so that's half of what I'll ask you for on the test. And now I want to know the sign, so we got to know what to do with that coordinate. What would the sign be?
1/2.
Yep, it would be just the y value, which is 1/2. Okay, that's the sine of 30 degrees. All right, let's look at the cosine of 135. Okay, so we have trouble because that's not in quadrant 1. We can draw it. Where's 135? Quadrant 1, 2, 3, or 4?
Quadrant 2.
Yep, it's in quadrant 2. Closer to the x, closer to the y, or right in the middle?
Right.
Yeah, 135 is right in the middle. And when you make a triangle, to figure out how far over and how far up, what kind of triangle is that one?
Right triangle.
A right triangle, can you be more specific? In terms of the ones that we studied 2 right triangles this week.
45, 45, 90.
That's the 45, 45, 90. Yep. How long is each leg in a 45, 45, 90?
Root 2 over 2.
Yep, they're both root 2 over 2. Now, when we write the coordinate for 135, we've got to be careful because we're in the second quadrant. So how would you write your coordinate for 135 degrees?
Wait, it would be negative root 2 over 2 and then
Yep.
just root 2 over 2.
Negative root 2 over 2 because we're going left. Positive root 2 over 2 because we're going up. Okay, so there's our coordinate. And now they want to know specifically just the cosine.
So negative root 2 over 2.
Yep, negative root 2 over 2. All right, so the first thing we're going to look at in this one is we got the tangent of 7 pi over 6. What do we need to figure out to be able to do all of that?
Degrees.
That might be a step in the process of figuring out what we need, but what is it we really need?
Coordinate.
We need the coordinate. If you need to change the degrees to get the coordinate, that's fine. But the coordinate is what you need. All right, so does anybody remember how much pi over 6 is? 30. And then it's times 7. So what are we looking at for an angle?
210.
So that's a 210 degree angle. Okay, let's make a sketch. What quadrant is 210 in? Yep, it's in quadrant 3. Is it closer to the x, closer to the y, or right in the middle?
X.
Yeah, this is closer to the x. So it's going to look something like that when you make your triangle. So we have to figure out how far over and then how far down. Which right triangle is this one?
30, 60, 90.
Right, it's the 30, 60, 90. So we have a long leg and a short leg. What's the length of the long leg?
The long leg.
Yeah.
Root 3 over 2.
Yep, the long leg is root 3 over 2. And how about the short leg?
Half.
A half. Right, now just be careful when you write your coordinate because you are in quadrant 3. What would your coordinate be?
Negative root 3 over 2 and half.
Negative root 3 over 2, negative 1/2. And now they want the tangent. What's the formula that we use for tangent?
X.
Y divided by x. When we divide those, what's going to happen?
The negatives and the 2's will cancel out.
Yep, negatives cancel, the 2's cancel, and what are you left with for now?
You're left with 1 over root 3.
Yep.
And you move the root to the top by making it root 3 over 3.
Right, and when we clean that up, it's going to be root 3 over 3. And that's the tangent of 7 pi over 6.